Morning and welcome to Seafood Bisque Day. Did you ever hear about the guy who was on the seafood diet? He saw the food and he ate it.
Good one.
Thank you. Thanks a lot. So anyway, we have, don't be too crabby, it's just a Monday morning. Pull yourself out of the hole. Here we go. If we're looking on this 3.1, which is reference angles, what we're doing is we took the first chapter and it was on reference angles, identities like the reciprocal identity, the ratio identity, the Pythagorean identity. We made proofs with it. We did substitutions. We drew angles in standard position. And then we moved from that chapter on to chapter 2. And chapter 2 difference was we no longer drew our angles in standard form, but we drew them just as a right triangle. And we drew story problems with right triangles in them. And on those right triangles, we labeled everything in the diagram, and we solved some of those problems, involved two equations and two unknowns. It became a little bit trickier than the normal type of story problem that you've seen. In this chapter 3, we're going to be moving back to chapter 1 and thinking about all of those identities, as well as looking at new information, but it's going to build on chapter 1, and we're going to be going back to drawing things in standard form. And so today, what we're going to be looking at are things called reference angles. Reference angles are going to be the angle that's measured always between the x-axis and the terminal side of an angle. All of those triangles that we've talked before about drawing in to the x-axis and not the y-axis were done that way because the focus was on reference angles. Now we're going to explain why we're drawing them to the x-axis. I said just draw them to the x-axis, we'll explain it later. Today we're going to find out why you're drawing them to the x-axis. In the book, on page number 116, it's just a reminder, make sure that you are studying consistently and not cramming at the end. Just a reminder. It seemed like there are a lot of students that were trying to solve a lot of those story problems at the end of last chapter and got stuck when they became more difficult. So do it consistently throughout. In the book, they have a reference angle that is labeled as a theta and a hat on it, or a caret, and that's going to mean reference angle. I will probably label mine as a reference angle, R angle. It's shorthand for it. And as you look at this, these are the rules that the book has in terms of finding a reference angle. And in my opinion, it's somewhat hard to memorize those because it's easy to make a mistake. But let me go through and just draw it and show you why this makes sense in the drawing. The first angle, if I draw this, will be this angle in the first quadrant, and your theta is actually equal to your reference angle. It's the same angle. Again, theta starts at the x-axis and goes around. Your reference angle is always going to be from the terminal side to the x-axis. But then let's go to the second quadrant. And if I were to look at the second quadrant here and think about this angle as it goes around, my theta is going to be here, and this angle right here is going to be my reference angle. Well, how do I determine that reference angle in that second quadrant if I'm given my theta? The way that you get it is to really take 180 degrees and subtract off this angle, and that will give you what the reference angle is. So 180 minus that part gives you the remaining part, which is the reference angle. Similarly, if you looked at going into the third quadrant, This is going to be your reference angle. How do I get my reference angle? I go all the way around to this angle, which is your theta, and then I subtract off 180 degrees, and that will give me my other part. So I'm doing what makes sense. I'm not memorizing this. I'm just doing what makes sense on your theta and your 180 or 360. Lastly, if I were to look at an angle down in the fourth quadrant, if my theta went all the way around here, how do I figure out what this reference angle would be? Well, I would take 360 all the way around, subtract off my angle, and that's going to give me what's left. Or I can think about, like if this is 310, 310 plus what gives me 360, 50 degrees. Get your own system. I would recommend not trying to rely on that list. I would do it by the drawing, and it's basically a part plus the part equals a whole type of concept. Show the reference angle of 30 degrees. That means in each of the angles in the quadrants, show what it is with a 30-degree reference angle. For starters, you have 30 degrees. That's going to be the same as your theta. Then we go to the next angle, which is going to be this angle. Your theta would be 150. Your reference angle is 30 degrees. Continuing along, we have this angle, which is actually 180 plus 30, or 240. And your reference angle is going to be 30. And the last one shows a reference angle of 30 degrees, and that's going to be 330. Each of these angles drawn, each of these thetas have the same reference angle of 30 degrees. By applying Santa Claus, you're going to see how to evaluate each of those main angles. So if I just looked at, for example, the sine of 30, I could go to my table and look up the value, or I could draw in a triangle and remember it's going to be 1 radical 3, 2, and therefore it's going to be the sine of this is 1 over 2. It's positive because of all of them are positive in that quadrant. But if I go to the sine of 150, taking the same idea, I know the sine of 150, sine is still positive, therefore that's going to be 1/2. The sine of 210, drawing in that triangle, which we've done before, is going to equal negative 1/2. And the sine of 330 is equal to a negative 1/2. This is where we're going to make an observation here, and that is that all of these angles, sine 30, sine 150, sine 210, sine 330, give you the same exact number except it's either positive or negative. In fact, I can rewrite this, all of these trig expressions I can write as the sine of 30 degrees, or I could write it as a negative sine of 30 degrees. Each of these can boil down to a positive or negative sine of 30 degrees. Either one. I just have to figure out which one. So that's why we use reference angles. I don't want to find the angle, the sine of those bigger angles. I want to find the sign of the smaller reference angle, and then just remember it's positive and negative by Santa Claus. But Santa Claus would get a lot of that seafood bisque stuck in his beard. Reference angle. Reference angle, we have 30 degrees, which we did before, and these are what I found out in the previous slide. And the main observation, this is the main hitter of today, is the trig function of theta and the trig function of the reference angle only differ by a positive or negative. The way I know if it's positive or negative is by Santa Claus. Trig function of theta and trig function of a reference angle only differ by a positive or negative. That tells me that I want to take my trig function of an angle and rewrite it as a trig function of a reference angle and then evaluate that if it's positive or negative. My table, your table that you have, has all angles between 0 and 90 degrees with special angles between 0 and 90 degrees. And so if you can get a reference angle in that quadrant, you can use that table to get these numbers. Moving ahead, what I want to do is just go through step by step on how you would solve for questions like this. What is the sine of 240? What is the tangent of 315? What is the cosecant of 300? And the directions are, find the reference angle, use Santa Claus to find out if it's positive or negative, and then rewrite the original with the reference angle and positive or negative, and then evaluate. What mistake I usually see is students will forget about Santa Claus and drop the negative sign. The way that you prevent that from happening is in this step right here. You say, this main expression is equal to that expression, which equals your answer. They're all equal, and I'm not forgetting to do something at the end of the problem. So how do I do this sine of 240? The first thing that I would do is draw it. We know it's going to be in here. We know this is 180 degrees. And what I want to do, well, I could draw in that this is actually 240 now. But what I want to do is I want to put the reference angle into the drawing. That's something that I haven't done before. So I have done before, but I didn't refer to the reference angle. The reference angle right there is going to be 240 minus 180 gives me that rest of that angle. So that's going to be 60 degrees. At this point, I'm going to see that I want to write the sine of 240 is the same as the sine of 60, because it's a reference angle, but it differs by either a positive or negative. And I'm going to remember in that quadrant, Santa Claus tells me that the sine is negative. So that's why I have a negative here, I have a negative here, and then when I evaluate from here to here, carry the negative sign down, and the sine of 60 is radical 3 over 2 by my table. I want to do every one the same. Draw the picture, draw the reference angle, put in exactly the same, and if you follow those steps, these should be pretty easy. At no point do I have to follow those rules of third quadrant, taking my theta, and subtracting off 180. I don't need that. I'm always thinking to myself, what is the angle that gets me back to that x-axis? It's 60 degrees by my drawing. Let's go to tangent 315. I want to figure out what the reference angle is by drawing it, positive or negative, rewrite it with the reference angle, and then evaluate. 315 is in the fourth quadrant. I know 360 is the whole thing. Now I can see that what's remaining is 45 degrees. And I can remember Santa Claus is going to tell me if it's positive or negative. If I'm looking at the tangent, I know in the fourth quadrant it is going to be negative. I now think, how do I rewrite it? So it's exactly the same, negative tangent of 45 degrees. How do I evaluate negative tangent 45 degrees? I go to my table and I see what is the tangent of 45, and I see that that is equal to 1. Doing the same thing for the third one. Cosecant of 300. I want to draw. And I'm going to see that I have 300 here. Again, this is 360, 300 all around. You're going to see that what is going to be the remaining angle? The remaining angle is going to be 60 degrees. And so this right here is 60. Again, C in that quadrant. I go back, fill in the table. I have, for number 2, sine is going to be negative here. I go back and I rewrite it. Negative cosecant of 60 degrees. I'm not happy with that cosecant. I could say, you know what, now you have 2 ways of doing it. You could say, I remember cosecant of theta is 1 over the sine of theta, the reciprocals. If I just find the sine of 60 and do the reciprocal, I'm done. So what I would remember at this point is sine of 30 is 1/2, so the sine of 60 is to be radical 3 over 2, and if I flip it, it's going to be radical 2 over radical 3. If you don't like doing that, then you could say it's negative 1 over sine of 60, which is really equal to a negative 2 over radical 3 through a couple of steps. This would be radical 3 over 2. You'd have to multiply by the reciprocal and ultimately get there. One last comment, which is somewhat common sense, but I need to address it. If you have angles that are outside of 0 to 360, you want to put the angle inside 0 to 360, and the way to do that is either by subtracting or adding 360 degrees. For example, if you had 495 degrees, when you subtract off 360, you get 135 degrees, and therefore you can easily see your reference angle. What does that really mean? It means at 490 degrees, you're doing an angle like this. But again, you always want to get a reference angle that's between 0 and 90. So what I want to do is take the 495, subtract off 360, and get a coterminal angle, which would be now at 135 degrees. The trig functions are going to be the same at that angle, so now what you want to do is evaluate, and you're looking at that reference angle, and you see that's going to be equal to 45 degrees. How do you know? That's 180. How do you get the blue one? You can take 180, subtract off 135, you get the 45. It's like the whole 180 minus the part 135 gives you the other part. Or you can think about it in terms of 135 plus what gives me 180. Get your system, stick with it. Don't forget to taste the soup before you serve it. Thank you.